In this question, we're told a square has lengths of 2 centimeters. The midpoints of the sides of the square are joined to form another square. This process is continued. The first 3 squares in the process are shown below. Find the sum of the perimeters of the squares if the process is continued indefinitely, and give your answer in the form of a plus b square root c centimeters, where a, b, and c are all elements of natural numbers. Okay, so some key terms here. So we're told the midpoints of the sides of the square are joined to form another square. Okay, so this, starting off, is a Pythagoras question. So this blue triangle here, I'm going to draw that out separately. So I'm going to have lengths of 1 and 1, and I'm getting those 1s because it's half of 2. And the midpoint of 2 would leave me with a 1 and a 1. So working out the hypotenuse then, so that would be the square root of 1 squared plus 1 squared. So just using Pythagoras' theorem, so that's square root 2. So that means now that the sides of this square now are all going to be root 2. So now I need to find the length of the next square inside this, and to do that, I'm going to focus on this triangle here. And that red triangle, so I'll draw that out here, and the sides of that will be root 2 over 2. And again, root 2 over 2. It's root 2 over 2 because it's half a root 2. If the length of all that side of the square is root 2, half of it has to be root 2 over 2. So again, we're going to use Pythagoras for the hypotenuse. So that'd be square root of root 2 over 2 all squared plus root 2 over 2 all squared, and that will equal 1. So that means the sides of this square in the middle are 1, 1, and 1. Now we're told that the sum of the perimeters of the squares is continued indefinitely. Okay, so let's get the perimeters of these squares. So the first square has sides of length 2 centimeters. So if all the sides are 2 centimeters, 4 times 2 will be 8 centimeters. So that's the perimeter of the first square. The next one then had sides of root 2. So 4 times root 2 will just be 4 root 2. And then the next square had sides of 1 centimeter, so that'll just be 4 centimeters. So that means the sequence is 8, 4 root 2, and then 4 centimeters. Now we're told that this process continues indefinitely. So because it's continuing indefinitely, we're going to use the sum to infinity formula. So again, this is in your logbooks. Now to find my R, so common ratio, I'm going to divide the second term by the first term. So 4 over root 2 over 8, and that will just be equal to root 2 over 2. And just to check this, I'm going to see if I divide the third term by the second term, will I get the same answer. So I put 4 over 4 root 2, so that will get me 1 over root 2. But then if I rationalize the denominator of this, I would end up with root 2 over root 2 times root 2, so that'd be root 4, so root 2 over 2. So I'm getting the same ratio, so I can see that that is correct. So that is my R value. So R is equal to root 2 over 2. So my A value, the first term, is 8. So 8 over 1 minus root 2 over 2. Now I'm going to put this straight into my calculator. And that gives us then 16 plus 8 root 2. And that's the final answer then. And you can see as well in the question, they say to give your answer in the form of a plus b of root c, where a, b, and c are all natural numbers, and I can see 16, 8, and 2, they're all natural numbers. So that's the question done.